Can everybody hear me? Perfect. All right, so my name is Alex Fedorov. I'm head of engineering at Rider Capital. And today I'm going to talk about feature toggles, trunk-based development, and continuous delivery. So just a little bit more about myself. Besides being currently at Rider Capital, I also am ex-Pivot from Pivotal, which means that I was a software engineering consultant there. We did a lot of stuff that I'm going to be talking about today, and obviously, over time, this has evolved further. I had 20 years of programming experience, did a lot of code in different languages, and has been doing professional experience a lot as well. I've done all stacks, so starting with DevOps and ending with native mobile on both iOS and Android. I also blog at my little blog called tdfellow.com, and it's about coding, quality, testing, professionalism, and so on. So, why they talk about feature toggles at the DroidCon? Well, the feature toggles are popular these days for some reason, I guess because Atlassian had this article where they said that they no longer recommend Git flow, so everybody is buzzing about feature toggles, but this is not the only reason. Also, I had a talk about fearless deploys on Friday evening, by the way, at DroidCon last time I was at it in Berlin in 2019, and I also gave this talk, updated version, at DevBreak last month in France. And of course, you can later after my talk if you want to take a look at it. But the point of this talk was that I have only mentioned and touched on the feature toggles a little bit, and there was a lot of questions after the talk to me about feature toggles. And I spoke with one of the attendees, and it became clear that the whole point of feature toggles and trunk-based development is a topic of its own for the full talk. So that's what I decided to do. And feature toggles, obviously they enable continuous integration delivery. Without feature toggles, you can't always do that. So you need them to have that in your toolbox. And besides that, they also enable you to do trunk-based development. What's the trunk-based development is when you push to the main branch every commit that you do. You don't branch out. Just to give you a recap of my talk that I had before, essentially, I spoke about the nature of software development and how whenever you implement anything, you always grow complexity. And as you grow complexity, it becomes harder and harder to understand the code, to communicate with our developers and business, and therefore that leads to more and more bugs and misunderstanding. And as a result of that, you get a slowdown, where over time, you get slower and slower and slower in your feature development. And the solution for this is to constantly work on your foundational architecture and software design to improve what your application can hold in it, what kind of complexity it can handle. Obviously, not in real world, but some kind of fantasy world, the ideal solution would be to always start with amazing architecture and with all the bells and whistles. But in reality, you're not going to get any stuff done if you start this way. So instead, what we do in software development, we start small, simple, and then we build on top of that, and we improve our foundation as we go. Right, and to improve it as you go, you need to do a lot of refactoring, and you need to have a good test suite. And the best way to get that test suite, by the way, is test-driven development. And if you do that, there's a very, very good cause for doing continuous integration. Because every time you refactor something, even if it's just a small refactoring or a bigger one, if it sits on your branch, that means that this work is still wasted. It's an inventory that sits around without delivering value. And if you continuously integrate, which means that you push that to other developers, and other developers can continue on and build on top of your refactoring, and maybe add the refactoring there on, then they're getting value from it. Obviously, if you do continuous integration and trunk-based development, you have a trouble with code reviews. So you can't do like gatekeeper kind of code review where there's a developer who reviews your code and says, oh, this is wrong, we kind of merge this, let's fix that first. Instead, you merge things or you push them to your main branch without that type of formal code review. What you do instead, you replace it with so-called, as I call it, instant code review. That's where you get the comments on your code as you write it. So if you have like a bad variable name or structure or duplication, you immediately get a comment from another developer, and this is called pair programming. Or you could also practice mob programming. Obviously, there is always a saying that, well, but I need an external eye, somebody who didn't see the code for a while, to give me more feedback. That's why we do pull requests. There is a way to solve this, which is rolling pair rotation. That's where you change your pairs every day. That allows you to have a situation where the bigger the piece of work is, a feature or ticket or whatever, the more eyes have seen the problem from the beginner's mindset, from open mind, where they are external eye, and they can give you that feedback. And this also leads to knowledge transfer among the teams. I call it knowledge pollination because it just basically spreads throughout different teams. So this is a recap of what I was talking about. And I just barely touched on continuous delivery and feature toggles and trunk-based development. So I'd like to continue it in this talk and say that all of this, that system, that you, by the way, don't have to implement in full. You can develop it over time. You can start small and expand your practices. That enables you to do proper continuous delivery. And what I mean by proper continuous delivery, I mean that you made some changes and you just push them to production. You make a release. But the problem with this is that if you use any kind of Git flow or branches, then you can't do that. So you need trunk-based development. And if you are using trunk-based development, then what do you do about unfinished features? Or features that are not complete or not accepted. Maybe they aren't working correctly yet, or maybe there are still things missing, where you hide them behind feature toggles. That's why this talk is about feature toggles and how to do them. Why would you want to have continuous delivery anyways? All right. Well, there are a few things. It improves your cycle time and makes you faster to the market, which means that it takes you less time to complete certain changes and also get feedback on them. And you don't have to complete all of the changes. So for example, if I want to do a refactoring in a code base, and let's say the refactoring that requires 3 weeks. So what I can do is to just start a refactoring and show a pattern in one place of the code base, communicate it to other developers, push that to main branch, agree with them that this is a good idea, and then they can take the torch. Every time they encounter old pattern in the code, they can replace it with a new pattern. Of course, that means that my refactoring actually will not take 3 weeks, but maybe will take a year. But it will be spread out throughout the feature development and different parts of the code. And basically, business will not even notice that we're improving our code, but the code will be constantly improved 0.5% a day in plus. Then another thing with continuous delivery is that you are reducing the waste. And by waste, I mean the work in progress type of waste. So every time you have a feature, refactoring, or anything that is incomplete and is not delivered to your customer, or not delivered to your other developers to build upon, I consider that an inventory, which means that you still need to maintain that code. Maybe you need to maintain the branch, make sure that it's always up to date. But the value that is embedded in this type of, you could say, asset or this inventory is not being used by anybody yet. So essentially, you're paying the price for maintaining it, but you're not getting the value yet. So, and the longer you stay in that stage, say if you stay in that stage for a few weeks, then you're losing that value. You're losing that maintenance cost. And when you do continuous delivery, then both your other developers, other members of the team, and your customers get the value early as they can, actually. Then if you do continuous delivery, that will force you to think, how can you deliver safely very frequently? So as a matter of fact, it will reduce the risk of releasing, because that's the only way to release so often is to reduce the risk. You will now have a choice. It will also force you to lower your batch size, which means that you will try to make your features smaller. You'll try to slice them better so that you can deliver them earlier, or deliver parts of them earlier so they actually make sense from even customer's perspective. And in lean, the lower batch size would expose any inefficiency that you have in your process. So from Lean perspective, it's a really good tool to reduce the batch size because suddenly every problem in the process that was hidden before because we were allowing large work in progress or large inventory to accumulate, now suddenly we have problems. And these problems are good because before we didn't know that we had problems, but we still had them. They were still slowing us down, but we didn't know where. Now, once we reduce the batch size and we're running very, very small tickets that can be implemented very quickly and delivered to the customer, what happens is that we'll see where are the bottlenecks. And we can think actively, how can we improve them? We can think how we can improve our processes. So, I mean, if you're doing like Scrum by the book, the book itself says that you must improve every week. So it's just a starting point. It's the same here. Any process that you have is a starting point. And if you have a system that allows you to identify where are the bottlenecks, you can actively do something to improve on them, which means they can become faster as a result of that. Obviously, if you do continuous delivery, there mustn't be any manual steps, right? So you will have to automate a lot of things. You'll have to improve your CI pipeline, make it faster, make it more efficient, make sure that you remove as many manual steps as possible because that will allow you to do continuous delivery more smoothly. And finally, because of this need to reduce risk, reduce the batch size, and make the releases more frequent, you will naturally start gravitating towards better software engineering practices, such as test-driven development, pair programming, and so on. Obviously, yeah, you get more frequent feedback, you get less bugs because you increase your quality, and you are adopting better practices. You are able to run quick experiments. So for example, if somebody has an idea, and they can just develop something and throw it out there in production, you can do that, right? So before it was harder to do because your release cycle was large. And most of all, if you're able to do this kind of thing and you don't need to wait blocked on code review or QA or what have you, you'll have a happier development team. Happier development team means better retention. So you have team members who stay longer with your company. It's really good. I spoke a lot about branches and how they're problematic. Well, think about this, that branches in Git and in other VCS that have branches exist for sole reason to delay the integration of code from one developer to another, or from one developer to production system, or to a deployed server. Then it's kind of opposite from continuous integration, what we are trying to achieve. Right? So if you want to integrate continuously, the branch is antithesis of that. And they cause conflicts. So the longer the branches are, the more conflicts you'll have. So the best thing is avoid them if you don't want to delay your integration. Obviously, if you do want to delay your integration of the code with other developers, do that, of course. When you develop on a branch, it's actually OK to make a commit that's low quality, like some kind of work in progress, or maybe like an experimental thing, or you're just playing around and fooling around, and maybe you're just trying to see, oh, is this working? And you're maybe not following all the practices that you should. Maybe you're not writing tests. And then you're thinking to yourself, oh, well, when I'm going to be ready for code review or for merging that, I'll fix that. Well, do you know what happens? People don't fix that stuff, so it goes to production. So this is another problem with branches, that they allow this lower quality commits to happen. If you do trunk-based development, then this is not allowed, right? So you have to make sure that whatever you're committing is good. So another problem with branches is the longer they live, the longer it is that you can allow them to live even further. So say that if you have a branch that lives for a few hours, you might think to yourself, oh, this is a nice bell and whistle that wasn't asked for, but I can still do it in 5 minutes, so I'm going to add it. But if you have a branch that was living for, let's say, 2 weeks, then it feels OK to spend one more day doing something that may be unnecessary for the feature or ticket or whatever you're working on. So it kind of smashes this definition of done. It becomes less clear, and it's easy to continue working and continue expanding the scope of what you're trying to change. So it becomes a kind of like a feature creep or refactoring creep, and so on. So you don't have these limits. And as I already said, it increases work in progress, which is waste, because this is the stuff that you worked on. You need to maintain that over time. And it's also painful to maintain, especially if you get frequent conflicts. But it's the stuff that doesn't bring you any value yet, because you didn't integrate it, you did not release it to your customer. Another problem that it encourages bigger units of work. So if you do branches with code reviews, and if you wanted to slice down your tickets or features to really, really tiny slices, then there's an issue is that you will have to create a branch for each slice and go through code review for each of the slices. It feels natural to bundle them up instead. So basically, branches are limiting how thin you can go with your batch size. And another problem with branches is that they give you very, very slow and late feedback. What do I mean by this? I mean that when is the best time to receive feedback on your code? Or on the maybe architectural decision that you're making? Immediately, once you made it, right? And let's say that you're working on a feature and you had to make a few architectural choices, you made them, and then it turns out later in the code review that you had a faulty assumption in the first choice. And the second and third choice is dependent on the first choice. So you have to throw away like 60, 80% of the work, maybe 100% in worst case scenario. So this is the problem of the slow and late feedback. The best way, if you can write code and get immediate feedback, and obviously, you know, I really like pair programming, ML programming, and they give you that feedback. Somebody immediately says that if you're making a mistake or you're having a faulty assumption, or there are other options that are just better and you can agree on them. Another problem is that having access to branches reduces collaboration, because we as developers, maybe not all of us, but majority of us, we naturally are trying to escape collaboration, even though collaboration is good, because collaboration allows us to deliver great things. Because one person, no matter how great they are, cannot deliver great things because they can focus only on so many skills at a time, and they have so much time in their day. So to deliver something amazing, something great, something that potentially changes the world, you have to work as a team. So you have to collaborate. But the problem with a branch is that when you have the opportunity to collaborate, you have a choice to delay that opportunity, delay the collaboration, because you're working independently on your branch and you're not touching anybody and they're not touching you, so you don't have to collaborate yet. You have to collaborate later when you want to merge this stuff, or when you merged something and you need to tell another person what happened. And maybe you're stepping on each other's toes, maybe they need to do rework, maybe you need to do rework now. So because of this late collaboration, it's a problem. It's because we naturally tend to avoid collaboration, and that's not good. Also, having the branches with code reviews makes refactoring hard. If you're just refactoring, like, I don't know, maybe a name of the variable, that's fine, right? So you can do that. But let's say that you want to make an architectural change or change the pattern slightly. Now you have a feature development, and you notice in the middle of the feature that if you did this change, it would be really easy to implement the feature. So you have first instinct is to make the refactoring. But then maybe you do it once, twice, and then your colleagues tell you feedback. Oh, it's really hard to code review your feature pull request because it has this big refactoring inside that's as big as a feature development itself. Could you please create separate pull requests for this? Now, next time you're developing a feature and you think, oh, I should refactor this, you're going to stop, oh, well, I'll need to create 2 branches now and maintain them, make sure that I merge one. This creates like delays, and I have to wait. It becomes annoying, so you opt to not do that bigger refactoring, while it was the right decision to do it. Okay, so trunk-based development kind of solves these problems. Of course, it has its own challenges, and I'm going to tell you how trunk-based development looks like if you're using Git. So you look at the code, identify what is the next thing that you want to change, make a small incremental change, probably using test-driven development. So you write a failing test, you make it pass, you do a few refactorings, and at the logical step where you think you've completed one of the behaviors required by a feature or behavior change or bug fix, you're done, you run a test suite, they're green, you make a commit, you write a good message, what you've done actually, and then you rebase from your main branch. You are on the main branch, by the way, right now. You don't have any other branches. You rebase from the main branch, and you push. What that does, that makes sure that all the code that other developers worked on since last time you committed and pushed is on your machine as well. And also, if there was any communication from other developers that they've done something, they refactored something, introduced a pattern, or they found out something that is important for you to know, you could already use that. You could already use that in your feature in the middle. If you had branches, that would be tougher. Additionally, if you are pushing something that is of importance to other developers, you can also now tell them, hey, this thing is in main, please rebase and use that stuff, or do the same thing. So you can really give the value to other developers and receive value from other developers much, much earlier. And of course, this is a cycle, so you go to step 1 and you keep doing that over and over and over again until you're done with what you're working on. Now, as I said, trunk-based development has a few challenges. First challenge is that you don't have any kind of gatekeeping mechanisms anymore. So you don't have this, oh, we will block this pull request because it really uses bad architectural pattern, or it just plain has a mistake, like incorrect behavior. No, you don't have that anymore. So this goes directly to main branch, and you have a problem in the main branch. So the question is, how do you handle it? Well, one thing is that you use this instant code review that I'm talking about, aka pair programming with rolling notation, so you get a benefit of third-party eye looking at the code who haven't seen it before. But this is, of course, not enough. Sometimes you have a pair of people working on a small feature. They make a mistake, or they make a faulty assumption. They push it. And how do we do next? Like, this is already in main. Oh, easy. Another developer notices that, for example. And it's also good practice in trunk-based development to, every time you pull, to just scan through the code that you're pulling. Last commit. So that's basically kind of code review, but it's a very quick one. And if you see any irregularities or something weird, you talk to another pair or another person, like what is going on there, and try to figure out. And basically, if you agree that there is something wrong or something needs to be changed, you just quickly pair up a mob and fix it and push it to main branch again. It literally takes 10, 15 minutes, sometimes a bit longer if the change is bigger, but it's a really, really fast process. Now, of course, another feature or another challenge of trunk-based development is the presence of these kind of incomplete features that don't fully work. And you don't want to show them to the customer, because customer will be like, what is going on? Why I click on this button, nothing happens? Right? So you don't want to show that. And this is where feature toggles will come in, and I'll focus on the rest of the talk on them after this slide. But also, trunk-based development requires these small self-contained changes, which you're putting in these small commits, because they're supposed to work, at least from developer perspective. So they must be passing all tests, and they must make sense. And you do that by applying test-driven development, acceptance test-driven development, continuous refactoring, and incremental design. Of course, if you need to run test suite before you push, and you push often, let's say every few minutes, maybe every Pomodoro timer, so every 25 minutes, you need the test suite to run quickly enough. So interesting thing that trunk-based development forces you to find ways how you can fasten your test suite, how you can make it faster. Or it enforces you to choose different architectural pattern. Let's say that you want to use bounded context from domain-driven design, or maybe you want to use microservices. And then you create independent components or libraries where it's enough to just run test suite for that library to be sure that you didn't break anything, because they're very, very independent from each other. So there are ways to make your test suite faster, even if it's currently already very slow. And another thing is that all of this, what I'm talking about, requires certain level of team maturity, so the team needs to be ready. So just to give you an example, that at Ride, we had 2 teams that wanted to do it, but they weren't ready themselves. They knew that. And once they felt that they're ready now, they started doing it. So it's actually a very good approach. So you start without it, and then when the teams that want to do it become ready, they start doing it. Obviously, you need to be a very good professional. You need to care. You need to use good practices, and you need the discipline, because you need to always keep all of this in mind and not slip into old habits. All right, let's focus on feature toggles, what the talk is about. So feature toggle, it's just a button where you can switch the light on and off, but the light is your feature. or part of a feature. It doesn't have to be a full feature. And in terms of UI, somewhere in admin panel, it might look like this. So you have feature ABC, you can it's turned on production, and feature XYZ is turned off on staging, or on production as well. And on staging, for example, you have everything turned on because you want to test your features on staging environment. There are two major usages for feature toggles. One is that you have an incomplete feature and you want to either show or hide it conditionally, because you want to test it partially, but you don't want to show it to actual customers. And another one is when you had existing feature and you needed to make significant change to its behavior or to how it looks like, or both. And then what you do is that you show conditionally old version of that feature or new version of this feature. And interesting thing about this is that you must make sure that you're not duplicating the feature. So it's not just copy paste of the old feature and then change it. It's rather you extract the common parts of the feature, of the old feature and what you're about to write, and then you write on top of that. So you're reusing the parts that are common, and you have the parts that are different. Okay, how the feature toggles actually look like? Well, the simplest feature toggle is when you just don't allow customer to have even UI access to the feature. So there's nothing special. There's just no button, no menu, nothing to access the screen with a new feature. That usually works when you're developing something entirely new, like new section of the application. But this is a rare scenario. This is only when you build something entirely new. A little bit more simpler feature toggle is when you have a simple if statement that relies on a constant, and then you can substitute that constant with your build tool, for example, with Gradle. This is a really, really primitive way. This is how you start. This is your first feature toggle. Probably will look like that, unless you already want to jump into something more advanced. Then, of course, as you start doing these if statements, you realize that, oh, I need to test this, and it's tough to test constants. I also need to do other things, and it doesn't look right. So you decide to create an abstraction, maybe something like feature toggle service. Now, this thing can be dependency injected, and you can mock it in tests. By the way, in the tests, you also check what happens when the feature is on, and you check what happens when the feature is off. Then you can go really advanced with abstractions. So you can use one of the Kotlin goodness or anything else that you want. So this is up for your imagination and what works. As I already said, that if you have this abstraction, you can easily test drive it, because you can inject it in your components, your elements, in your logic, and just mock the outcome off and on and check what happens. So when we use feature toggles, these could be very different things. So it could be just new features that I already said that are not finished. It could be changes of UI UX, where you're changing it significantly and you don't want to just release it entirely, or you have it in progress. When you're changing the actual behavior of the application, so maybe business logic that you have in the client side or in backend. And by the way, front end and backend and client side can all share the same feature flags, and they can use them together. When you change some core business logic as well, when you sometimes when you need to delete a feature, but it's like overarching and is touching everything, it's hard to do it in one go. So what you do is that you start these deprecations and removals, and you can do them also with feature toggles. So it's kind of anti-feature toggle, because when it's on, the feature is gone. When it's off, the feature is present. And yeah, it can be used in both sides. So where does the actual feature toggle config lies in your application? There are multiple ways to do this. 5 minutes later. Okay. There are multiple ways to do it. So you can be a beginner and you just put it directly in your application. It's just constants or whatever. You can be advanced beginner and you put it in cloud as a file, maybe on a S3 bucket, and people can edit it. When you gain some experience with feature toggle, you'll see that this is sometimes failing. So you want to add defaults and cache, because you want the application to work offline, or you want if somebody screws up the file and misses the closing curly brace in JSON, you want to make sure that works. And then next step is when you actually want to move this responsibility of storing feature toggle, making them dynamic to the backend and store them in database. And here, interesting thing is that you can start controlling not only on and off, but also what type of user that is. Is this a beta user for whom we always open up our features? Or do we also have alpha users? Do we have like early adopter or something like this? We can also do canaries, where you can roll out a feature to 10% of your audience with this. And you can have any extra logic. For example, if you have a special type of customer who legally can use that feature, you can show that feature to them. But let's say that other customers cannot legally use that feature, so they don't see it. You can use that there. And finally, there's an expert mode where you're using a third-party tool, like Unleash or Launch Darkly, and your backend needs to communicate with this. But that means the backend also needs to be resilient to that tool being down or not available, or to timeouts. So it needs to have cache, defaults, and circuit breaker. How do I release? Well, you can actually go continuous delivery extreme case. You release every commit, or you at least prepare it to be released, so that's just one button to release. Or you can have like a manual job in your CI that you need to click that takes the last commit that's green and releases it. Or you can make Git tags. So every time on the main branch you make a Git tag, it triggers the release process. And finally, if you have bigger changes and you need to roll them out and you're not sure how your customers will react, so it's not about correctness now, it's about reaction. Maybe people will not like the feature. You roll them out using canaries like 10%, 20%, and so on. Another thing that I want to say is that if you have too many feature toggles in your code base will become kind of a monster. Like it will be hard to comprehend because there's a lot of these switches. So what you need to do is to have a work in progress limit instead, which means that the team can have only so many feature toggles at a time. And if they want to add a new one, they need to remove something old. That is also an idea of lowering the batch size, which if you have a WP limit of, for example, 3 feature toggles, but you need 4, maybe you have a problem in the process that you can fix. My suggested WIP limit is because of pairing is a team size divided by 2. So let's say that you have one single feature team, and they have WIP, let's say 6 people, they have WIP limit of 3. Of course, you need to constantly improve the development process so that you can get your WIP limit down lower and lower and lower to that amount. And obviously, you need to clean up these. So once your features are ready to go and you release it to production, everything is good. Like your monitoring shows good. There are no negative feedback from customers. It's actually being used. You can see that in analytics. Then you start going and cleaning up. So you remove all the conditional statements. You remove all deprecated features if necessary. And you remove the feature toggle. And then you can add new feature toggle for next iteration. The only caution is that you need to design your feature toggles in such a way that it would be really easy to find them. So let's say that if you design it with an abstraction, you can try to find usages or something like this. Obviously, you need good monitoring and crash tracking, because when you deliver so frequently, you need to know if something is wrong so that you can either disable the offending features or roll back. Finally, I want to conclude, just the last slide, is that if you use all of this, so XP, test-driven development, refactoring with continuous delivery, trunk-based development, and feature toggles, then your cycle time will reduce from potentially weeks to minutes. Your agility and speed will increase, and your time that you react to feedback will reduce, which means that as soon as you get customer feedback or product feedback or internal department feedback, you can just do it, implement it, push it, and already have a test version that they can check it out, and then a bit later you can have production release. You increase quality by doing this because you have to refactor all the time. You have to follow right practices because continuous delivery doesn't work otherwise. You're reducing the risk of release because you're doing so often. You're so good at it that for you it's not an event. It just happens, and it's like normal thing. It's like breathing. You're releasing all the time. And finally, you reduce development costs because you're reducing waste. That's all. Here are some useful links, and I open to questions.